Good afternoon. Joining us on the line now is Shohini Ghose. She's a professor of physics and computer science in Canada. She's the recipient of several awards, including a TED Senior Fellowship. And in 2019, she was among 25 women scientists worldwide featured in a UNESCO exhibit in Paris. Her book, Her Space, Her Time, tells the inspiring stories of long overlooked women physicists and astronomers who discovered the fundamental rules of the universe and reshaped the rules of society. Welcome to the show, Shohini.
Thank you. Great to be here.
Oh, it's great to have you with us. Thank you for joining us. And thank you for writing this wonderful book.
Thank you. I'm so excited to share these amazing stories with people all over the world.
Yes, it's amazing to read and see about these women that I was embarrassed to have not heard of. But I think a lot of people won't have heard of many of these women because of something that's been labeled the Matilda effect.
Yes, that's right. This is such a common phenomenon that, yes, it has a name. It's named after the woman who first called it out. And the problem is that when women do have these amazing contributions in science, they do not actually get the recognition that they deserve. And often it's attributed to perhaps one of their colleagues who happens to be a man. And often things like awards like Nobel Prizes are usually given to the man rather than the woman. And this is so common that it has this name, the Matilda effect. So let's hope we can change it and get rid of this effect.
Yeah, that's such a shame, isn't it? I mean, I think a lot of people will know the story of Marie Curie and her husband, who of course worked together, but it was all kind of veering towards him at one stage, wasn't it? The recognition.
Absolutely. Even in her case, he was the one who was offered the Nobel Prize, and he actually stepped up and was this great example of an ally and a supporter of his wife, and made it clear to the Nobel Committee that it was she who did the majority of the work, and they finally grudgingly said, "Okay, fine." So I think that's what it took, but it shouldn't have to take that. I mean, I think we need to move forward and make sure that we acknowledge and celebrate everybody. This doesn't have to be some kind of a zero-sum game where if you celebrate women, somehow that takes away from anybody else. Everybody wins. So there's really no downside to changing this.
Yes. No, it's one of those things that it's a shame that men and women need to come into it. It should just be the person who's acknowledged, but it's the fact that women haven't been acknowledged that it is a thing and it needs to be discussed.
Absolutely. I agree. That's well said. Science is for persons.
Yes.
Yeah.
So let's talk about some of these amazing women. When we talk about man landing on the moon and walking on the moon, you know, it's the men that have made these historic achievements, the astronauts, but there are lots of women behind the scenes who made that happen.
Absolutely. And in fact, even this sort of well-known phrase about a giant leap for mankind already ignores the fact that this is about all humans, not just mankind. And also that there were many, many thousands of women actually who contributed, because that's what it took. It took, hundreds of thousands of people from all areas, both in science and management and, people who were looking into how we can survive in space, all these people who were working together. And among all those thousands, there were many, many women. So it was actually quite difficult to pick who I wanted to talk about in the book, where I talk about the entire early days of the space program. But there's several that came to mind, and I tried to bring into the story those who made these really big contributions, but unfortunately were left out of this story that we tell. And one of them was this woman named Joyce Neighbors, who was the one who was involved in calculating exactly the trajectory of the second stage rockets of Explorer 1, which was the very first US mission that put a satellite into orbit. And back then, there were no real sort of previous examples of what the calculations should look like. So this was all from scratch. She didn't have good observations or measurements to work off of or anything like this. This was purely about being accurate, careful, and just doing great science. And that's what she did. She led that team. And of course, she got it right because Explorer 1, as we know, did put a satellite into space. But she didn't really get the credit she deserved. She was invited to sign the flight chart, which is a great honor, but she was actually told, please don't put your full name, just put your initials, because we don't want a woman's name on the chart because it might undermine the credibility of the chart.
Wow.
So this is, yes. So a lot of the stories have this sort of, bittersweet kind of feeling because they have all these wonderful achievements and yet they kept being derailed or undermined or pushed to the side, which is so sad because we could all celebrate and really be inspired by these women.
Definitely. Tell us about Margaret Burbridge.
She was also an incredible woman who was involved in, one of the biggest discoveries, I think, of all time, which is, in fact, the beginning of time, which is the Big Bang. So she was an astronomer who made all these observations of stars, and she, together with her husband, as well as with two other physicists, wrote this incredible paper which mapped out exactly what happens in the life and death of stars. Just by the observations she made, they could actually create this entire story of what's going on deep in the cores of stars and how they use hydrogen for fusion to create energy, which is, of course, something we know and take for granted today. But if you think about it, it's not that easy to figure out exactly how that process happens because we can't go look inside the cores of stars, of course. All we can do is look at these observations through our telescopes and try to back out what the story really is. So that's what she did. And not only do we know about the hydrogen fusion of stars, she and her team were able to understand what happens once the hydrogen runs out, and then there's a helium fusion stage followed by other heavy elements. So there's an entire sequence of very complicated nuclear physics processes that happen. And if you calculate it all out, you can actually figure out why we have all the different proportions of elements that we see in the universe. And that was one of the big ways to confirm not only the life cycle of stars, but explaining what happened in the early universe right after the Big Bang, why there's more hydrogen, and how all the heavy elements were created. So that actually created completed the entire story of the Big Bang.
Amazing.
And that was her. Yeah.
Amazing. So that's Margaret Burbridge. Then what about Mary Anna Palmer Draper?
Oh, she was an amazing woman as well. They were all such wonderful, inspiring women. She was somebody who actually kickstarted this whole entire area of star cataloging and observations, because when she and her husband, who is actually more well known, were both observers. They used to make their own telescopes and then use that to observe the stars. She and her husband were the first to actually capture this, what is called a spectrum of another star. And what the spectrum is essentially it's a way to collect the light in the telescope and then use a prism to separate it out into all of its different colors and then capture that on a photograph. Now, keep in mind that back then, there weren't, nice digital cameras or anything like that. It wasn't a one-click thing at all. So we are very spoiled with our cameras. But back then, they used to use glass plates with special coatings, and you had to, carefully make sure that the light from the telescope would hit the glass plate, but no other light could hit it because otherwise you'd spoil the image and things like this. So they were the first to do that. And that technique, or what we call spectroscopy, then became widely used again because of Anna Draper, because in fact her husband died fairly early, but she wanted to continue doing astronomy. So what she did was, she was a fairly wealthy woman. So she actually provided funding to the Harvard University Observatory and also donated their telescopes and created this new fund called the Draper Memorial Fund in her husband's honor. And that fund was used to hire a whole bunch of women actually to do the observations and catalog all these different spectra of stars, and eventually led us to understand what stars are made of and things like, as I was talking about, the Big Bang, how to measure distances, all kinds of incredible observations were made. In fact, hundreds of thousands of stars were observed thanks to Anna Draper.
Gosh, wonderful. And back to the moon landings, Mary Golda Ross was instrumental with that too.
Absolutely. Mary Ross was, in fact, somebody who was a true trailblazer because she was actually the first indigenous woman aerospace engineer. She was actually the great-great-granddaughter of a very famous Cherokee chief called John Ross, who was the one who led his people, in the famous Trail of Tears, all the way from Georgia through to Oklahoma, where they made their new home because they were pushed off their lands. But he helped start this new Cherokee nation in Oklahoma. Of course, went through many, many challenges, but he was really focused on making sure that kids got an education. And so I think he would have been really, really proud of his great-great-granddaughter, Mary Ross, who chose to study mathematics. She loved mathematics, but she actually secretly loved astronomy even more because she wanted to go to space and explore space. But she never actually used to say that much just because she wanted to be taken seriously. But during World War II, she actually started working with Lockheed in their group that was developing military planes. And she turned out to be so good at it that they kept her on after the war, actually paid for her to get an aeronautics degree. And she became part of this very elite team that started developing, recon missions, satellites, and, started developing rockets for NASA. So she was involved in this team that built this rocket called Agena, which we don't hear of as much as, let's say, Atlas, which is a famous, huge, giant moon rocket. But in fact, there's always a stage 2 rocket to all these big missions. So you need the big rocket, of course, to launch off from Earth. But then you need a second stage to actually give you exactly the right kind of thrust to get into orbit or to be aimed at wherever you're going, whether it's Mars or the moon or anywhere else. And Agena was that rocket. And it was such an amazing workhorse and so reliable and so flexible that it had many, many missions and could also actually be steered once it was in orbit, which was really, really helpful, of course. So that was what she had helped develop. And in fact, it was a very, very important part of the lunar missions, as well as the early days of probes that were sent to Mars, as well as to Venus and all over the solar system.
Wow.
So, yeah.
It's incredible. And where did your interest in science come from?
Oh, my gosh. So I was one of those nerdy kids who loved Star Trek when I was a child back in India when I was growing up. That was actually the only American show that I watched back then. That was the only one that was available. And that made me dream big. And I also, of course, loved math and science. So that helped. And, one thing, I guess, led to the other. And eventually I chose to study physics in my undergraduate days. And I was hooked ever since. Eventually that led me not to exploring space, which was, of course, something that I've always been fascinated by, but I worked with this professor whose research was actually in quantum physics and quantum computing, which you might not think is linked to space, although of course we do need this. This is the fundamental theory that explains everything in the universe. So it is actually linked to everything in the universe. But I ended up working with him, and now I explore this new field called quantum computing, which is a way to use quantum physics to build computers and do information processing tasks and even do sci-fi things like quantum teleportation. So in a way, I've sort of connected back to my early days watching Star Trek, where, they used to beam up and down from planets and so on. So that's wonderful. What I do now. Yep. And I feel like I'm still an explorer. So it may not be in space, but I feel like I'm exploring all these new worlds in the quantum realm.
Yeah. Oh, that's fantastic. And I know more and more women are getting interested and going for the STEM jobs. But why do you think there's still a lack of women interested in these subjects?
I'm not sure if it's actually a lack of women who are interested. For example, in my case, I was absolutely interested. That was not the issue. And I think for many young girls growing up, they are absolutely interested. In fact, there's no evidence that shows that there's some natural difference in interest. It's that we're told often that, these are the things that we're supposed to be interested in. These are the things boys are supposed to be interested in, things like this. So there's a lot of environmental factors, or, what you hear or what you see on TV, who are the scientist role models, for example. One of the reasons why I wrote this book, so that it normalizes the idea that anybody can be a scientist. So there are lots of, perceptions and biases about who can be a scientist. And also there's actual barriers. So there's been studies which show that when you compare the experiences of, different scientists in the workplace as well as in the classroom, actually, you see that there's differences in terms of who gets the teacher's attention, for example, more, or what resources are available for research for men versus women. How fast do different people get up the career ladder? What kind of prizes and awards and recognitions are people getting? And is the process of hiring and promotions fair or not? There's actually a lot of data which shows that there are clear structural differences. And to me, yes, that's of course obviously unfair and makes me outraged that this is still happening. But on the other hand, it also gives me hope, because these are obviously things that we can change. It has nothing to do with our biology. That is harder to change. But these kinds of strict structural made up systems absolutely can change. So I hope we do better going forward.
Oh, definitely. Well, we will do with people like you. If people want to get a copy of your book, it's called Her Space, Her Time. It's available on our website, tre.radio. It's by Shohini Ghose, who we've been chatting with today. Shohini, thank you so much for joining us.
Thank you so much.